All right, we're on the Unit 6 review guide, topic 16C, so questions 16 through 21. So these are solving equations. So again, an equation is something that has an equal sign. So we can see I've got an equal sign here. I have a fraction on the left and 2 on the right. So what I want to do is I want to get a common denominator. And once I have a common denominator, then I can just deal with the numerators. So think about like this. If I have x over 6 equals 2 over 6, I know that x has to equal 2, right? I can kind of ignore the fact that those are even there and just say, oh, x equals 2. So that's my goal here. Same thing with this. If I have x over 5 plus 1 over 5 equals 6 over 5, if they all have the same denominator, I can just deal with x plus 1 equals 6, x equals 5. So my first goal is to get a common denominator, and I'm looking for the least common denominator. So as I go through here, I'm looking at 4, 2, and x. And I want to know what is the least common denominator. Well, 4, between 4 and 2, if it was just 4 and 2, I would say the least common denominator is 4. But I also have that x that I need to include. We need to be fair and make sure that everything gets the same thing. Everyone needs all the same things in the denominator. So now that I have my least common denominator, I'm looking at changing these fractions into fractions over that least common denominator. So all of my denominators are going to be 4x. And I'm kind of looking at what was I missing. So if I look here at this 4 and this 4x, I'm missing the x. That's what I need to multiply this fraction by. If I look here, the 2 and the 4x, I would have to multiply by 2x to get 4x. That's what I'm missing. And then this last one, between the x and the 4x, I'm missing the 4. So once I've done that and I have a common denominator, I don't need to worry about the denominators anymore. Now I just need to worry about the numerators. So I've got 1 times x, which is just x, equals 2x plus 4. So I'm going to subtract x from both sides, and then subtract 4 from both sides, and I get x equals -4. Now, before I say this is my final answer, the other thing I need to be careful of is making sure that this answer works. And when I say make sure it works, I need to check all the denominators and make sure that if I put this answer into the denominator where I have an x, that it doesn't make the denominator 0. Because I can't have 0 for a denominator, and the reason for that is I can't divide by 0. A fraction is saying you're dividing. 1/4 is saying 1 divided by 4. So we can't divide by 0, so we need to make sure that it's not 0. So when I put this in here for x, it's not 0, it's just -4. So I'm okay. So I'm going to do number 18 a different way just to show you that you can. And this only works if you have a single fraction equal to a single fraction. So if you have a single fraction equal to a single fraction, you can cross multiply. So just like something like this, x over 2 equals 5 over 7. Something like that, I would say, oh, I cross multiply. 7x equals 10, x equals 10 over 7. So again, only if one fraction is equal to another fraction can you cross multiply. So this turns out to be x times x plus 11 equals x minus 1 times 2x plus 10. This gives me x squared plus 11x. And this one is a binomial times a binomial, so you need to box or FOIL it. So when I do that, I get 2x squared here, 10x, negative 2x, negative 10. So this equals 2x squared plus 8x minus 10. So now I say I have a quadratic, which means I'm going to need to get it to equal 0 and then try to factor. So I'm going to move all these things on the left over. I'm going to subtract x squared and subtract 11x. When I subtract x squared from here, I get x squared. When I subtract 11x from 8x, I get negative 3x. So now I can factor. I'm looking for two numbers that multiply to be negative 10 and add up to be negative 3. That would be negative 5 and 2. That gives me 5 and negative 2. So my first check is, if I put these numbers into the denominator, do they make it 0? No. If I put 5 in, I get 4. Here I get 16. Negative 2 gives me negative 3, and that gives me 9. So I'm okay on that end, but I also need to check for extraneous solutions. I need to make sure they both work. When I say work, I mean when I plug these answers back in, the left side needs to equal the right side. So I'm going to use my calculator to do this. I'm going to do 5 stow x and put in x on the top and x minus 1 on the bottom. That gives me 5/4. That's the left side. So as long as my right side also equals 5/4, then this answer is good. So my right side also gives me 5/4. So 5 works. Now we're going to check negative 2. So negative 2 stow x, and instead of retyping, I'm just going to go up and highlight what I typed in. So there's my left side. Enter, enter, I don't have to retype. So that gives me 2/3. So let's go back to where I typed in the right side. Enter, enter. 2/3 equals 2/3. They both work. So both of them are answers. I don't have any extraneous solutions on this problem. All right, so number 20. So I'm going to write these as over 1. You can turn any number into a fraction by putting it over 1. So now I'm looking for a least common denominator. I have x1, x, and 1. So my least common denominator is going to be x. So everything needs to be over x. So I've got 15 over x. This is going to be something over x. And the reason why I'm writing the 15 over x and the 6 over x is because they don't change. Their denominator is my least common denominator. Nothing needs to change here. There's nothing I need to multiply. But when I look at this, to get a denominator of x here, I have to multiply by x. So I have to multiply the bottom by x, but also the top. And the same thing here. To get this 1 to be x, I would need to multiply by x, so I need to multiply the top by x. So now that I have all the denominators are the same, I can just cross them out and ignore them. So I have 15 minus 4x equals 6 plus 3x. I'm going to add 4x to both sides. That gives me 7x on the right. I'm going to subtract 6 from each side. That gives me 9 equals 7x, or x equals 9 over 7. And if I check, it doesn't make my fractions be 0 in the denominator, so I'm okay. Number 17, I'm going to put parentheses here so that I know that that's one thing. It's kind of stuck together. I can't consider the x and the negative 2 separately. I need to consider the x minus 2 as one thing. So when I look at my least common denominator, I see I have an x. I'll need to put that as part of it. And I also have an x minus 2. So now, when I'm trying to figure these, they're all going to be over x times x minus 2. That's my common denominator. If I look at this, let's write what I already have. I have 2x plus 3, x plus 2, and 3x. If I look at this x here, and I look at the least common denominator, I'm missing x minus 2. So this needs to be multiplied by x minus 2. If I look at this in the least common denominator, I'm missing x. So this needs to be multiplied by x. And the same thing here, I'm missing an x. So now that I have the common denominators all the same, I can cross them out. This is going to be either boxing or foiling. For the lack of space, I'm going to do it in my head. So I've got 2x squared, 3x minus 4x gives me negative x minus 6. This I'm going to distribute the x to both things. So plus x squared plus 2x. And this is 3x squared. So So now I'm looking to combine like terms, and I'm also trying to get one side to be 0. So I've got 2x squared plus x squared is 3x squared. Negative x plus 2x is x. And then this minus 6. Oh, but I have a 3x squared on both sides. So they actually cancel. Right? If I subtracted it, I would get 0. So this means x minus 6 equals 0. If I bring this 3x squared over, 3x squared minus 3x squared is 0. So this gives me x equals 6. I check and make sure I can put 6 in without making any of these denominators 0, and I can. So that is my answer. On number 19, I'm going to write this over 1 so I have a fraction. And I'm going to factor this difference of squares to be x plus 1, x minus 1. So now I'm looking for the least common denominator. It needs to include this x plus 1 over here. I don't need to include it again, but I do need to include this x minus 1. So when I'm looking at what am I missing, let's write my least common denominator first. Okay, and then currently I have 4x plus 1 on the top, 12, and 3. When I look at this one, when I look at the least common denominator, I'm missing the x minus 1, so that's what I multiply the top by. When I look at this one, I'm not missing anything. This is the least common denominator to be multiplied. When I look at this one, I'm missing everything. And instead of writing it as x plus 1 and x minus 1 and then having to do the work again, I'm going to write it as x squared minus 1, because we know that these are the same. I factored this to get this. So now that I have all the common denominators the same, and cross them out. Again, this would have to be foiled or boxed. I'm going to do it in my head and hopefully not make mistakes. So I've got 4x squared minus 3x minus 1 equals 12 plus 3x squared minus 3. So I have a quadratic. I'm going to try to move everything to one side so it equals 0. So if I subtract 3x squared, I get x squared minus 3x. 12 minus 3 is 9. So subtracting 9 from either side gives me minus 10 equals 0. So two numbers that multiply to be negative 10 and add up to be negative 3 would be negative 5, positive 2. So x equals 5, x equals negative 2, but I need to check them. So my first check is to make sure they don't make any denominators 0, so they're good there. But then I also need to check for extraneous solutions. So we're going to say 5 stow x, and then put my left side in. So alpha y equals 4x plus 1 over x plus 1. So my left side equals 7 halves, so that means my right side also needs to equal 7 halves if this is a solution. So let's put the right side in. 12 over x squared minus 1 plus 3. 7 halves equals 7 halves. 5 works. So now we're going to try negative 2. So negative 2 stow x. And again, versus retyping, I'm just going to go up and highlight. There was my left side. Highlight, enter, enter. Tells me it's 7. I'm going to go highlight the right side. Enter, enter. 7 equals 7, so both of these answers work. I don't have any extraneous solutions. All right, last one, 21. We need to find a least common denominator. I've got 2a squared, a, and 4a squared. So my least common denominator is going to be 4a squared. Let me see if I can put a little bit of separation between these problems. Okay, so everything is going to be over 4a squared. On this first problem, if I wanted to get from here to 4a squared, I would have to multiply by 2. So I need to multiply the top by 2. Here, I would need to multiply by 4a. So I need to multiply the top by 4a. And this is the least common denominator. I don't need to multiply by anything. So now I can ignore the denominators because they're all the same. This gives me 2 plus 4a equals 1. If I subtract 2 from each side, I get -1, and then divide by 4, -1/4. It doesn't make my denominator be 0. So make sure you check that.